Hello and welcome. Today, we're going to tackle a massive topic, data. More specifically, how we can use the science of statistics to turn all that noise, all that raw data, into something clear, useful, and honestly, pretty powerful. All right, let's dive right in.
I mean, just think about it. Every time you click something online, buy a coffee, or answer a poll, that's more data. We are literally swimming in it. But just having a mountain of data doesn't really help, does it? The real challenge and the real magic is figuring out what it all means. How do you find the important signal inside all of that noise? Well, that, my friends, is where statistics comes in.
You know, I absolutely love this quote. It gives us the perfect way to think about our journey today. Let's imagine we're building a road. Every concept we cover is like laying down another section of pavement. And by the end, this road is going to take us from a confusing mess of numbers to a place where everything makes sense.
And here is the actual blueprint for that road. First, we'll figure out what we're even trying to do. Then we'll learn the basic language of data. After that, the fun part, seeing the story in the data. And finally, we'll learn how to boil that whole story down to just a few key numbers.
Okay, time to start laying that foundation. Section 1 is all about the big picture, the real reason statistics even exists. It's the toolbox we use to turn messy, raw data into clean, useful information. So what is statistics really? When you strip it all away, it's the science of making better decisions with data. Simple as that. Now for today, we're going to focus on the absolute bedrock of that science, something called descriptive statistics. And it's exactly what it sounds like. It's all about learning how to accurately describe the data you have sitting right in front of you. All right, let's keep building our road with Section 2. Now, you can't just start paving over any old ground, right? You have to survey the terrain first, understand what you're working with. In stats, that means you have to understand your data. So, at the highest level, data really comes in two main flavors. First, you've got qualitative data. This is stuff that sorts things into categories or buckets. Think car brands, Ford, Tesla, Honda, or just a simple yes or no. On the other hand, you have quantitative data. This is all about the numbers, things you can actually measure. Temperature, your salary, your age. One tells you what kind, the other tells you how much. And we can get even more specific. There are three main scales. The most basic is nominal. These are just labels. The number on a football player's jersey is a great example. Next up is ordinal. Here, the order actually matters, but the gaps between them aren't equal. Think about t-shirt sizes. We all know a large is bigger than a medium, but is it exactly 1 unit bigger? Not really. And finally, you have the interval scale. Here, the order matters, and the difference between the numbers is meaningful and consistent. The difference between 10 and 20 degrees is the exact same as the difference between 80 and 90 degrees. Okay, so why am I spending so much time on this? Because this right here, this is absolutely crucial. You have to know what kind of data you're working with. It dictates everything. Literally every chart you can make, every calculation you can run. If you get this part wrong, your entire road is going to be full of potholes. All right, our foundation is solid. Let's get to the really exciting part in Section 3, visualization. This is where we stop staring at boring lists of numbers and start drawing pictures that actually tell us the story hidden inside the data. So let's pretend we asked 25 voters about their party affiliation. The raw data is just a messy list of words. The very first thing we do to make sense of it is create a frequency table. It's super simple. We just count how many people fall into each category. So we've got 8 Republicans, 6 Democrats, and 11 independents. Easy, right? But we can do so much better. And boom, this is where the magic really happens. We turn that table into a bar chart, and suddenly it's a picture. Our brains are just wired to understand visuals, to compare heights and shapes way faster than we can process a list of numbers. In a single glance, you don't even have to think. You just see that independents are the biggest group. That's the power of visualization. It lets you see, not just think. Now, when we're dealing with numerical data, graphs can show us something else that's really cool, the shape of the data. A very common one is this symmetric bell curve shape. Just think about the heights of people in a large group. Most people will be around the average height, with fewer and fewer people being really short or really tall. It makes this nice, balanced shape. But of course, data isn't always so perfectly balanced. Sometimes it's skewed. A positively skewed distribution is one where you have a long tail stretching out to the right. The classic example is income. You'll have most people earning a moderate amount, all clustered together, but then a few billionaires pull that tail way, way out to the right.
And you can probably guess the opposite is also true. You can have a negatively skewed distribution, where that long tail points to the left. Imagine looking at grades for a really easy test. Most of the class is going to get high scores, right? They'll be bunched up on the right side. But if a few students get really low scores, they'll pull that tail out to the left. Just seeing the shape instantly tells you a story.
So, we've built the roadbed, we've drawn the map. Now for our final section. It's time to put up some landmarks. We're about to learn how to take a huge, complicated data set and boil it all down to just a couple of really powerful, descriptive numbers. And that leads us to a pretty natural question, right? If you had to pick just one single number to represent an entire list of data, what number would you pick? How do you find that one typical value? Well, this hunt for a single representative number is what statisticians call measures of central tendency. It's a fancy phrase, but it's a simple idea. It's our first big landmark, a number that tries to capture the center or the heart of our data. We've got three main tools to do this. There's the mean, which is just the good old average we learned in school. There's the mode, which is even simpler. It's just the value that shows up most often. And then there's the median, which is the number smack dab in the middle of the list once you've sorted it. Now, the mean is great, but it has one big weakness. It's super sensitive to extreme values. Think about it. 10 people are in a coffee shop, and they each make 50 grand a year. The mean salary is 50 grand. But then a billionaire walks in. Suddenly, the mean salary skyrockets to millions of dollars. But is that the reality of the room? Not at all. The median, the person in the middle, is still making 50 grand. That's why for skewed data, the median can tell a much more honest story.
Okay, so we've found the center. But what if you have two totally different groups of data that have the exact same average? Does that mean they're the same? Not so fast. This question pushes us to find our second crucial landmark.
And that second landmark is what we call variability, or more simply, spread. If the center tells us what's typical, the spread tells us how typical that typical value really is. Are all the data points best friends huddled tightly around the center, or are they scattered all over the map? The best tool we have to measure this is the standard deviation.
And this is so useful. A great way to think of standard deviation is as a consistency score. Imagine two basketball players. Both of them average 20 points per game. But one has a tiny standard deviation. He's Mr. Reliable. He's going to get you right around 20 points night after night. The other player has a huge standard deviation. He's a total wild card. He might get you 40 points one night and 0 the next. Same average, but totally different stories. And there we have it. Our road is built. We went from a confusing mess to a clear path. So let's just recap our journey. 1. Always know what type of data you have. 2. Draw a picture of it. Visualize the data to see the story. And 3. Summarize that story with two big ideas. Where's its center and how spread out is it? If you remember those 3 things, you've got the core of descriptive statistics down. So we've gotten pretty good at describing the data we can see. But that opens up an even bigger, more powerful question. How can we take what we learn from a small sample, like a poll of 1,000 voters, and use it to confidently say something about what 100 million voters might do? How do you make that leap? Well, that is the next, even more exciting step on this road, and it's a topic for another time. Thanks for joining me.